I truly am. Sorry. These ones are tedious. I'm going to show you the process, okay? This says the maximum size fuse permitted to protect the primary of a 480 volt to 240 volt single phase, we are in single phase, 15 kVA dry type transformer is how many amps? Okay, we're talking about primary protection. The secondary conductors are 6 gauge copper THHN, THWN, and overcurrent protection is not provided on the secondary. Don't forget to check 240.4F, which we will do, and 240.21C in the NEC. Then pick the smaller permitted by Article 240 or Note 1 of 450.3B. Okay, so we have to do both of these calculations, and then we are going to do a comparative analysis, and we are going to pick the appropriate one for our circumstance. Okay, so first, let's go ahead and size the primary right out of 450.3b since we're there and we've been used to doing it. Okay, so I have a 480 volt single phase 15 kVA transformer, so this is pretty straightforward. I'm going to do 15,000, right? 15 kVA, and I'm just simply going to divide that by 480. No 1.732 because we are in single phase here. Okay, 15,000 divided by 480 equals 31.25 amps, 31.25 there, amps. Now, we are talking about a fuse. Let's take a look at this. Primary protection only. Okay, it said that specifically in there. Currents of 9 amps or more. Okay. I have 125% with a superscript 1. Remember that superscript 1 means we can round up. Lovely. So I'll take that 31.25 times 125%, 1.25. Well, if I clear it, it doesn't help. 31.25 times 1.25 equals 39.06 amps. Love it. 31.25 times 1.25 equals 39.06 amps. And we said I can round up, right? What a great day. I can round that up to 40 amps out of 240.6. Okay, so that's my number based on 450.3B. But now we gotta check 240.4 because there's always got to be somebody that's the party killer, right? They're the mood killer, and that mood killer is going to be 240.4. So let's go take a spin over and see what that says. Here we go. You're gonna love or hate this. Probably hate, and that's okay. Transformer secondary conductors, 240.4 is your protection of conductors. Okay, remember that one? We've done some work inside of there before. And 240.4F, it leads you right to in the question itself. This is the one we're going to be talking about. It's kind of a lot of words, but we'll break it down as best we can. It says single phase, other than 2-wire, and multi-phase, other than delta-delta. 3-wire transformer secondary conductors shall not be considered to be protected by the primary overcurrent protective device. Conductors supplied by the secondary side of a single-phase transformer having 2-wire single voltage secondary, or 3-phase delta-delta connected transformer having a 3-wire single voltage secondary shall be permitted to be protected by overcurrent protection provided on the primary supply side of the transformer. Okay, a lot of words. Single phase 2-wire is kind of what we wanted to isolate from that. This last sentence is what's going to be the most pertinent to us, though. It says provided. This protection is in accordance with 450.3 and does not exceed the value determined by multiplying the secondary conductor ampacity. So that's going to be the ampacity of this number 6. Okay, it says the secondary conductors, right? By multiplying the secondary conductor ampacity by the secondary to primary transformer voltage ratio. Made that a little confusing. Okay. Let's figure it out. We got this. Okay, so I am going to go figure out what a number 6 is worth. Okay, let's head over to that holy grail article 310.16. I'm going to find that number 6. Now, since we are talking about true terminations, we're going to be in that 75 degrees Celsius category, and that number 6 is worth 65 amperes. Okay, so I'm going to write that down. Let's write this here, 240.4F. That's worth 65 amps. Now, what that code article specifically said is I can take the current rating of the conductor, the secondary conductor, and it will be determined by multiplying the secondary conductor ampacity by the secondary to primary voltage ratio. Love this. Okay, so how that looks is like this. 65, I multiply it by the secondary to primary voltage ratio. So I will take my secondary ratio, which is 240 in this case, and I will divide that by my primary, which is 480. Okay, you set it up just like that. 65 times, and then you open your parentheses, secondary voltage divided by primary voltage. Let's do it. 65. Do you love this yet, or is it a hate? 65 times 240 divided by 480. I'll close those parentheses out. It's 0.5. You hate it? Oh, come on! 32.5 equals 32.5 amps. Okay. Strongly dislike. There you go. Okay. Now can we round that up or down? That's the next question we have. This is where I have to get crazy with the highlighter. Let's get another color here. Okay. 32.5. That doesn't land on something. Okay. This says specifically inside of here, does not exceed. Does not exceed. What that means is we have to round down. Okay. Does not exceed. You got it, Simon, 100%. So we are going to round that down because we cannot go over 32.5 amps. So we will round that down to our next standard size of 30 amperes. Okay, so I compare those two, and I have to make sure I satisfy both of their requirements. Okay, so in this case, 240.4 is going to win. I need to put that 30 on there. Okay, since that's how I chose to live my life and wire my stuff, that's the size protection I got to put on this bad boy. Okay, so hopefully that helps. I know those ones are tricky. You're going to have some of those on the quiz. I'm sorry. I'm so sorry.